You open up an AI builder, paste in a massive 1,000-word prompt detailing every feature of your dream application, and hit Generate. This is the current widely popular method known as vibe coding. For simple single-page websites or basic utility scripts, this approach works. The AI has enough context to spit out exactly what you asked for. But look what happens when you apply that same method to a complex system, something requiring relational databases, distinct teacher and student roles, and multi-step logic. The facade begins to crack. The AI loses track of its rules. It overwrites functional code and invents unrequested features because the context window fractures under the massive prompt. Global security protocols are forgotten, and database architectures mapped out earlier simply vanish into visual static. Monolithic prompts fail because they overload the AI's working memory with too many competing variables at once, leading to an inevitable breakdown in logic. To build complex software, you must move away from the mega prompt and adopt a 3-layer setup designed to manage that context window. The first layer is the constitution, often stored as an agent.md file. This is the widest view of the entire project. This file acts as persistent global context. The AI references it before taking action, broadcasting a constant pulsing signal of instructions. You use this file to lock in your tech stack, universal database models, and strict global security rules. For instance, if you require a teacher to approve every AI-generated grade, you encode that human-in-the-loop rule here. It ensures the AI cannot automate away critical oversight. Establishing a constitution ensures that no matter how deep the AI gets into specific coding tasks, it remains bound by the universal laws of your application. Once the macro rules are locked, we can acknowledge a simple truth. Complex software is just a collection of isolated modules working together. Layer 2 is the blueprints, or skill.md files. These define exact parameters for one specific module. You strictly feed the AI one single module blueprint at a time. This blueprint contains only the inputs, expected outputs, and database tables relevant to that task. Then we reach Layer 3, the execution. These are the actual prompts you type into the AI's chat box. Because the heavy lifting was done in the blueprint, these prompts stay incredibly short. You are simply telling the AI to implement the specific logic. By restricting the AI's context to a single module, you create a closed-loop environment. The AI only has access to relevant data, which forces it to remain precise and avoids the logic drifts that cause hallucinations. This 3-layer hierarchy dictates your build schedule. You build and test only one skill per chat thread before moving to the next. This creates a pipeline effect. Each module is built sequentially, so the output of the first stage becomes the perfect input for the second. After every successful module, you update the global knowledge file. This keeps your constitution current with the latest changes. An amateur treats the AI like a magic 8-ball, hoping a clever prompt will solve a complex problem. A professional treats it as a constrained computational engine. Generating complex code is not a matter of finding the right vibes. It is a matter of engineering a structural system that contains and directs the AI's focus.